This is IAM302. In this session, we'll be talking about how to stay ahead of your threat actors and how Amazon Cognito can help you with this objective. My name is Mahmoud Matouk. I am a solutions architect with AWS Identity, and I'm joined today by my guests, Alistair and Caleb from Dynata. In this session, we'll be talking about the expansion of online business and the risks that come with it, and how to lower and reduce these risks to your online business and to your customer using Amazon Cognito. We'll talk about how identity and taking an identity-centric approach to protect your applications can help with that. And we'll talk about taking a layered security approach with putting different security controls in the path of identity traffic to Amazon Cognito and to your application. We'll hear some insights from Dinata on their journey achieving exactly that. And I will close out with some detection and monitoring tips on what you need to keep an eye on in your identity traffic and how to detect deviations from the standard patterns and how to detect threat actors and isolate them. This is a 300-level session, so we'll be slightly technical, and we'll assume that you already know Amazon Cognito and used it before. This is how you benefit the most from this session. So first, online business is expanding like never before. Users are engaging more online. Maybe this started or peaked at the pandemic era, but it's not slowing down now. And with expanding the online business, this also expands your threat surface, and it brings more risks to your application. Just to highlight some of these risks, in last year's Internet Crime Report, the number of filed scams in 2023 doubled from 5 years ago, and the amount of lost revenue reported as above $12 billion. In another report from SIFT, it indicated that in 2023 alone, amount of account takeover attacks against fintech grew to 800%. The same report has several data points from other segments, and you will constantly see that the account takeover is the number one risk to online business these days. In the same report also, majority of users surveyed said they would abandon a brand because of an account takeover. And I think we all can relate to this. How do you feel when you receive this email that your data has been breached or your password has been exposed or something like that? So, does this mean we should slow down business growth? This will never happen. Online business will keep growing. So the question we should be asking is, how do I lower the risk to my online business, and how do I lower the risk to my end users? Identity is becoming the new security boundaries of these online businesses. Users come, sign up, sign in, and you can stop so many fraud at identity layer than you can imagine. Usually, any transaction fraud starts with an identity fraud. An attacker needs to use stolen credentials to access your system, or they need to forge as somebody else to gain access and then commit a transaction fraud. If you can catch as many of these at the gate and block them out, this makes your system more secure. And you can think about how to do this across three pillars or three venues. The first one is stopping fraud at the identity layer, doing enough detection and prevention there to make you safe beyond this layer. Preventing users from using compromised credentials, detecting weak credentials, using adaptive risk-based authentication, being aware of the user context and user behavior. All of these are things you can do at the identity layer at the gate. The second pillar you should focus on is vigilant monitoring. You need to be aware of what's going on in your identity traffic. You should be able to quickly identify any deviations from these patterns and identify threat actors and be able to block them and keep them away from your system. And the third one is continuous customer education, and this is a community thing that we all have to do together. So we have to first make it easy for end users to make good choices, good decisions, make multi-factor authentication easier for them to adopt, give them passkeys and WebAuthn when possible, and gradually this will improve the security posture of your end users and your system as well. How does Amazon Cognito help you with this journey? Amazon Cognito is a managed customer identity and access management service. Applications use it to manage user authentication and user sign-up and user profile management. And then applications get a token from Cognito, and they can use these tokens to access the backend. This is at a very high level how applications use Amazon Cognito service today. As a managed service, it comes backed with out-of-the-box security features available to your application. Things like verifying user accounts when they sign up, verifying communication mediums like mobile phone and email address, providing you with risk-based authentication, so detecting a risk, having a baseline of user behavior, and being able to detect deviations from this behavior. Giving you firewalls so you can protect against volumetric attacks and things of this sort. And of course, the secure storage of data and detecting compromised credentials as being used by end users. So all of these are out-of-the-box features you can get, but you also need to design your application and build your system in a way that benefits from these features and others. So to do that, it is always beneficial to have layered security approach, meaning that you have different security controls at different life cycles of the identity request. And probably in each layer, you can catch different types of threats. So let's dive into each one of these layers and see what controls and what actions can be done in every layer. The first layer of security is protecting network access or access perimeter to your identity layer. So if you are using Amazon Cognito, you need to use something like firewall. Amazon Cognito integrates natively with AWS WAF. And this allows you to put rules to protect access to this system from things like volumetric attacks, DDoS and whatnot, adding things like rate limiting, more advanced rate limiting, and you can rate limit your sign-up flow differently from authentication flow. Usually, traffic to identity layer is much different than traffic to your website. Users come to your identity layer, authenticate once, have a session valid for 1 hour. They can make thousands, tens of thousands, hundreds of thousands of API calls in your website without touching identity layer again. So usually, firewall rules on your identity layer should be different and configured in a different way from what's on your website and APIs. With this layer as well, you can do API filtering. For example, if you want to allow only sign in and sign up, but you don't allow profile updates, you can block these APIs on the firewall. You can also use managed rules from AWS and the marketplace to block bad reputation sources. And of course, you can do geofencing as well, whether it's an open fence, you operate in certain countries and you block others, or a closed fence, you operate only in one specific geographic location and you keep everything out. And this allows you to handle lots of volumetric attacks at the gate. Requests go to this layer. It either gets thumbs up and moves to the next stage, or it gets thumbs down and blocked at the gate. This is a very good starting point for you if you are using WAF or planning to use WAF. This blog post gives you the different endpoints that Cognito has and some starting configurations for your endpoints and also how to tune them according to your business needs. The second layer of security is the threat detection services in Amazon Cognito. So once requests pass this firewall and lands in Cognito, Cognito uses its threat detection services to detect compromised credentials or weak credentials during certain flows when a user is signing up or changing their password. And you have the ability to block these credentials from being used. It also creates a device key for the user, so it has a map of what are the known devices for this user, and it also collects data from the client side, the user context data, which indicates what is the device posture, what is the device fingerprint, what are the known locations for this user, and using all of this data, it calculates a risk for the authentication attempt or the sign up or the account verification, whatever traffic is coming to Cognito in this case for this particular user. Requests that don't have a risk just gets thumbs up and move on to the next one. Requests that have a risk allows you to decide what to do with it. Risk is categorized between low, medium, high, and then you can decide on every level what you would like to do. You can simply allow the request to pass through if you just are looking for logging of this information, or you can choose to do optional multi-factor authentication, which means Cognito will attempt to do an MFA, but if it's not possible because the user doesn't have a phone number or something, then the request will be allowed. Or you can require MFA, meaning that same as before, but if MFA is not possible, the request will be blocked, or you can decide to block the request right out. In all cases, you can also, the request will be, you can also choose to notify the user, so send out an email asking the user if this was a legitimate request or not, and getting feedback. This feedback is recorded, and this is very valuable because we know now that the request is for sure risk or not risk. And all of this data is logged inside Cognito. So you have a log record of the event, the risk calculated, what was the results, what are the authentication factors solved, and so on. These 2 points, the feedback from users and the event logging, are very important threat intelligence data that is used to improve the risk engine within Cognito, again, understanding the user behavior and user context. But it can also be used elsewhere in your system. So, for example, if you are running a financial transaction, you can query this data and see what was the risk score for this user. Did we have a risk in the last 3-4 days for this user? And based on this, you handle the transaction differently. We heard many feedback from customers that they want this data to be more portable, and we are investing in this area. You can expect enhancements in this area to make this data more portable and streamable to other destinations. These features, the advanced security features or threat detection services in Cognito, can be turned on in audit-only mode, which means it will just log the events, it will not take action, or it can be in full function, which will start enforcing as well. And you have flexible configurations. You can configure compromised credentials, for example, to detect compromised credentials in certain flows, and whether you want to allow or block these credentials. Same thing with adaptive risk-based authentication. You have choices of what are the actions you need to enforce in every risk level. Usually customers start with a more lenient approach, so you maybe allow everything in low and medium and optional MFA and high risk, and then you work your way out from there. When users start adopting multi-factor authentication and the security posture of your system increases, then you can move to full enforcement as explained here. A very important aspect of using advanced security features is data collections on the client side. So if you are using adaptive risk authentication and advanced security features in Cognito, your application needs to use an SDK on the front end. This is an AWS or Cognito provided SDK. This SDK does the data collection, the management of device key and the device fingerprint on the client side, and passes this information automatically to Cognito through the API calls. So Cognito now have the device information, the fingerprint, the location, the history about this user, and all of this data combined allows Cognito to calculate the risk, return this risk to Cognito service, and then based on this, take a decision, allow, deny, or block. This also has some more information about how to use this SDK in your application. I cannot stress enough on using this SDK because the quality of the data you get from a threat detection system depends with a high degree on the quality of user context data that's coming into the system. So if you're not using this, it will still function, but it will have false positives. Using the SDK will help with that. Many customers use proxy integrations with Cognito. So rather than having the client connecting to Cognito directly, you have a proxy or a backend integration for one reason or the other. You can still do data collection on the front end using the same SDK. Now you need to make some API call to create this context, user context data. It will maintain it the same way. You need to send this encoded data into your proxy layer. And then when you make an API call to Cognito, you need to provide this user data and provide the IP address of the client through a confidential client. That's why you see here this purple line adds a secret hash to the request. And then Cognito is going to function properly, even if it's being integrated with from your backend or from a proxy layer. So again, it's very important to make sure that this data collection happens properly and propagated to Cognito so you reduce false positives and improve the results of the risk engine. These are a couple of more links for you. Again, how to configure Cognito to accept user context data, and the other one is just a pattern on how to build proxies to Cognito if this is of interest to you. So we talked about the network protection with WAF, the threat detection with advanced security features. The third layer is Lambda extensions that Cognito has. Cognito has different lifecycle hooks that allows you to integrate with Lambda functions to run at different stages. And this can be used for user validation or integration with third-party services. So I'm just highlighting 3 here, but there are others. So in pre-sign up Lambda trigger, for example, before the user is created in Cognito, you have the ability to use this trigger to verify certain things about the user. Maybe you need the user to be approved or received an invitation first. So you can do this with the pre-sign up. Pre-authentication is performing similar things. Before the user is authenticated, you might run some checks against them. Is the user still active in your backend or something like that? You can also use these Lambda triggers to integrate with external third-party threat detection services. So if you have a business-specific threat detection or you have an identity verification service you want to integrate with, you can do this from the Lambda triggers, and this allows you to get feedback from this external service, and based on this, decide whether to move on with the request or block it somehow. In pre-token generation, you can do things like customizing the identity and access token. This allows you to both suppress data, so if there are more data in user profile than what the application needs, you can hide this data or suppress it. If you want to add more additional data from runtime information or back-end data from your back-end, you can do this in the pre-token generation Lambda trigger. This creates transient changes to the token, so it doesn't change user profile, but allows you to get more data in the tokens than what is in the user profile. So these are the different stages and the different security controls you can put in the path of identity flow. And you can catch different types of threats at every layer. So you can catch volumetric attacks with WAF, you can catch account takeover and weak credentials with advanced security features, and then you can do custom business logic validations in the Lambda triggers. By the time a user is authenticated and makes it to your application, you have a reasonable degree of confidence that this user has been vetted and this is a valid traffic. You still need threat detection in other layers of your system as well, maybe at the transaction level, but at least you stopped so much fraud at the identity layer than before. Customers will have different ways in implementing these according to their business profile. So now I would like to invite Alistair to talk about Dynata and how they took a similar approach to mitigate risks in their system and reduce the risk. And did this work for you or not?
Well, that's a great start. Hi, my name is Alistair. I'm a director of engineering at Dinata, and I want to talk to you about what our journey was into integrating Cognito into the platform. Okay. So for me to do that, first I need to tell you a little bit about why protecting the user accounts is important to Dinata, which should be important to everyone. So we are a market research company. We are the world's largest first-party data provider, which what that means is we have a lot of people that come into our websites. They join our websites to provide information to us first party. What that means is that they are answering surveys themselves, right? They're giving us their data willingly and knowingly, okay? So that's what one of those websites look like. That's Opinion Outpost. It's one of the brands that we have. And once users sign in, they can see some survey opportunities that they can take, and they receive points for those. That's why they do it. That's why they take surveys. They can use those points to then cash out for different rewards. They can, for instance, get money in PayPal. And that's actually what makes us a very good target for hackers, right? Users don't see us as a bank. They don't think of our accounts as, I should have the same amount of security that I should where I have my money. But the reality is that they have money with us, right? So we have to take that extra step for them to say, we're going to secure your accounts, we're going to do everything that's in our power to stop those threat actors. Okay, so where were we before Cognito? Okay, we had about 200 plus different websites, those brands that I mentioned. Across them, we have about 70 plus million users. And across them, we had 3 different types of homegrown authentication mechanisms. Across all of these, we actually received millions of daily password stuffing attempts, right? It was every day you could look and you could see something. We had no MFA to stop this because we had our own homegrown authentication mechanism. And because of all of this, we spent 20 plus hours every week on intrusion prevention. These are some of the brands that I mentioned there. Please feel free to join, by the way. Shameless plug. Okay. So this was our proposed solution with Cognito. We have both web apps and mobile apps that we want to use the ID token for those because we get the advantage of having the attributes that are part of the pool, so we don't have to do the database trips every time that we want to determine who someone is. We use WAF on top of Cognito. This is really important for the rate limiting and for the bot protection, which you also see a lot of activity for. Then on the Cognito side, we do one user pool per brand. Even though we have 200 websites, that's only 34 different brands. That's based on the uniqueness that we have for the email, so a user can only belong to one of those websites for a brand. These different websites are basically regionalized versions of the same brand. So that would be one way that you would determine how many pools do I actually need. That was the reasoning for us. And in all of them, we have advanced security turned on. Now, because of this complexity around the multiple brands and some other things that we wanted to make so that our users had an easier experience, less friction, we do use the Lambda extensions that Mahmoud mentioned. Okay, so that's for two purposes. The first one is integration into our legacy auth service that should actually be services, if you remember. Right? That's for us to have like a seamless transition, which we still have some APIs that still talk the old legacy auth service. And what we do is we enrich that ID token with the token for the old legacy system. That way we can have a seamless transition where we don't need everyone to make changes at the same time. And the other side is for the messaging, we have Pinpoint, right? So we use Pinpoint for the multi-branding. That's what allows us to customize the message board in translations and in branding to the specific user. Now, the Lambda is also very useful for the online migration. I cannot stress that enough, right? We didn't have to do any preparation for doing the migration. It was just setting up the Lambdas, talk to the old authentication system, migrate user send. Now, you can do the Lambda multiple ways, but we decided to do a single Lambda function that handles all the different triggers, all the different trigger sources, they call them, but just have one single Lambda across all of those 34 brands. Based on some configuration, we detect what brand it's actually supposed to be, what backend service it should talk to, but that simplifies concurrency management, for instance, and code maintainability. Now, as for our WAF setup, this is what we would suggest are like good practices for having something on top of Cognito. You'll actually see this also on the blog post from AWS. The first thing we would want to do is have an IP allow list. That's going to be at the top of your rules. This is those IPs that you do not want to run any of these other rules for, so that you can make sure that your internal users make it through. Anyone that's run afoul of some other exception that you want to make sure they don't do again, right? You'll have that allow list. Then you'll also want a deny list, because even though WAF has a lot of capabilities and a lot of built-in rules, there's going to be cases where you have a threat actor that you want to stop immediately, right? And even though this is playing whack-a-mole a little bit with the IP deny list, it gets the job done immediately. Now, the risky country is for the geofencing that Mahmoud mentioned, right? This is where you'll want to say, I don't even need to see any traffic from this country. I'm not on that market. Then why are you even allowing it, right? Go ahead and just block it outright. Now, for the rate limiting rule, because this is exclusively for WAF, it's only for authentication purposes, we went with the lowest possible value that it allows, which is 100 requests in 10 minutes, so 10 requests a minute. This is what we suggest, to be honest. No one should be authenticating as much or refreshing tokens as much. Right? This is really the value that we decided to go with, and it has worked perfectly. Now, we also do another one that is not the standard one, which is the part of the bot protection. We do the silent token challenge. Again, I mentioned we are not a bank. We don't want to introduce extra friction, but we do want to try to protect the accounts. So we went with a silent token versus like a CAPTCHA. This is just a JavaScript challenge. Hopefully you guys are familiar with it, but that actually gives us a lot of value. And the cheapest way to get that is through the bot protection. Now, as far as the two managed rules that we mainly use, it's the Amazon IP reputation list, which has a lot of value. So it's basically the deny list, but managed by Amazon. And then we also do the anonymous IP list. The only thing with that one is we have seen a lot of false positives with the hosting provider rules, especially because of ISP providers in Europe and other countries, which sometimes run afoul of this. Right? So that's one that we only have enabled in count mode. Everything else we have in block. And as I mentioned, we enable bot control because that's the one that allows us the JavaScript challenge. We have it in count mode right now, but we have seen a lot of good benefits from it, that if we actually switch it to block, it would get a lot of the volumetric IP attacks that we're seeing. So it's actually something we're considering on turning on. Now, going back a little bit to our auth service so that you can understand why it's also important for us to go through the Lambda route, is our users can come to our websites through two different places. Our main login page and some emails that they get that have a link that they can click on and authenticates them. For the ones that come to the login page, we talk to Cognito through the POS or auth request that gives them full access tokens, And then they're directed to our survey wall, where they can take surveys, where they can cash out, they can do other activities. We also have a minimalistic survey wall where they cannot do all of these things. They can only take surveys. That actually does a custom auth request with a signature that's based on Inforce from AWS. And they get a restricted access token from this, which doesn't allow access to all of the different APIs, which we then validate on the APIs themselves. Now, our user pool configuration is, a little bit standard, but I still want to highlight some things about it. You will always want to have these two settings on, in my opinion, which is allowing the token revocation so that you can stop a bad actor when you detect it. And you want to hide user existing errors because you don't want to give attackers any more information that you need to. No, users can put up with getting a generic error of saying, hey, these credentials are not valid versus, hey, that's the wrong password. Right? That's something that you'll want to do for them so that you can, again, give less information to your attackers. Now, we use only non-mutable fields as attributes, right? Those are an example of the ones that we use. So why is that? Well, these are going to be added to the ID token. So this is what actually saves you that database strip. If we added anything that was mutable, then we would still have to go to the database to make sure that we had the latest version. But again, this will vary on your use case, right? If some leniency there for having data out of date, then you might be able to add other things in here. Now, there's other reasons we'll go into detail later of why you would also not want to add anything that's mutable here. As I mentioned, we have two different authentication mechanisms, so we actually separated that into two different clients. Client 1 for the password auth and client 2 for the signature auth. These are the type of authentications that we manage in both. You'll notice from these that we do allow refresh token on either of those, so even the ones that sign in with links can still refresh their session. And we only allow the admin user password auth on client 1. This is for the proxies that Mahmoud was mentioning. For our mobile apps, the easier path of migration was to allow the existing backend for the mobile apps to talk to Cognito instead. So you can actually have a hybrid where in some cases you are talking to Cognito directly, and in some of them you might be using a proxy. Now, advanced security, right? Compromised and weak credential detection, that's what it's for, right? You want to make sure that you do that. What does that look like when someone is actually flagged? They get that on the log right there. You can see that used right next to it under the compromised credentials flag. This column doesn't show by default on the UI, by the way, so you'll have to go in there in the settings and actually show it. The one thing to note about this that you might not as easily find in the documentation is that password change requests are actually blocked. You get that error message that you see there. It's not like it's just flagged, it's actually blocked. So it's something that you'll have to make sure that you notify your users because it's a little bit ambiguous, right? It's not like they didn't pass the password policy, they were actually just blocked. In the case of this sign-in blocked, what happens is that the user is turning to a reset required state. So you can manage it on your side so that you immediately bring them into that reset required state where you can send them to the screen just to put in the code. Now, adaptive authentication, that's the one where we detect the risk level, and based on the risk level, we take an action. This is the one that we went with because we still wanted to introduce, as I said, less friction to our users. So this is actually like one radio box to the left of what you saw on Mahmoud's slide. We allow signing for low risk. We do optional MFA for medium risk, and we require MFA for high risk. We only notify the users on medium and high risk, especially when you start. Remember, this is a model in a way, so you want to make sure that you get a baseline of what your users are doing as regular activity before you notify them too much. Especially, to not introduce panic with how things are today. Now, this is what that looks like again. The last one in there was a high risk level, and it was blocked. You can actually see on the risk decision that it said that it was an account takeover. I actually did that one when I was testing with some credentials that I know were, stolen years ago. Now, in order to explain our Lambdas, I'm going to turn over the microphone to my colleague Caleb. Thank you for your time.
Thank you, Alistair. Yeah, so I'm here to talk about how we actually implemented Cognito as our authentication service and see how that looked like for us. So let's begin with kind of the most common, possibly, authentication that's out there, password authentication. So when a user comes into the website, obviously, they will put in their username, they'll put in their password, and that kicks off this authentication flow with Cognito. Cognito is then going to call a series of lambdas. The first lambda we call is this pre-authentication lambda. We use this as an opportunity to check a few features, few attributes that we want to validate and confirm are coming through as expected. So in our case, we have many brands and likewise many user pools. So one thing that we check at this point is this user trying to access the user pool that aligns with the brand that they're coming from. Now, it's possible that a user is not found, but that does not mean that the user is not one of our users. Remember, we have a legacy auth service, so it's possible that they've not been moved to Cognito yet. So the Cognito will call a lambda to trigger a user migration. We can use this lambda to log the user in to the legacy auth service. And if that's successful, then we're able to create that user immediately in Cognito, seamlessly moving them over to our new authentication. Cognito runs checks. So in cases where there are compromised credentials, or in cases where, during user migration, we're moving to a more strict password policy, the Cognito will flag the user as needing to change their password. So what it'll do is it'll generate a code. And we use this in a custom sender lambda to notify the user of this code, requesting that they reset their password. They can receive this code in their email and provide it to the client together with their new password, giving them the access to their account. Similarly, we could run into risky behavior, especially with advanced security. We have all these checks that are going on every time a user attempts to log in. So if something is not looking right, based on the configuration, we may have an MFA challenge that wants to get produced, or a notification that we want to send to the user. So we, again, will trigger our custom sender lambda, and based on the configuration, we will either send a block request, a notification, or perhaps an MFA challenge to the user. In the case of an MFA challenge, we will actually have an input then for that challenge on the website, or the MFA will be used to confirm. That way we know this user is in fact valid and should be authenticated. So now we have our user. We are confident as best as we can be at this time that they are legitimate. So let's go ahead and we want to get them their security token. But before we give them their token, we have an opportunity to apply a few user attributes to the token that are not natively with Cognito. So one attribute that we can add is actually our legacy auth service token. This allows us to give them access to legacy APIs that perhaps have not moved over to Cognito yet without requiring all these services to be updated before the Cognito merge. And that is our password authentication flow. So now, of course, as always, sometimes we forget our passwords. So if a user forgets their password, again, no worries, Cognito is there for us. We'll go ahead and check with Cognito. Cognito will find out, hey, possibly the user's not there. Again, not a problem. We're going to run that same user migration lambda that we ran earlier. Now, of course, in this case, we don't have a password. So we'll move them over to Cognito without a password. And Cognito will trigger them with a code, sending that over to our lambda, which will notify the user, and the user will input the code together with their new password, and then they will be prompted once more to log in. So that was an overview of our password authentication. Now we'd like to take a look at our signature authentication. This is where a user receives an email, and we want them to just click the link and get right in to be able to take our surveys. So a user can receive this email, they click the link, and the authentication gets initiated for them on the loading of the page. Cognito picks this up, and we're going to run that same pre-auth check that we ran earlier. Again, we're just checking, hey, are you trying to access the correct user pool for the website that you're coming from? This is really a kind of configuration check at this point. If everything looks good, we're going to let them enter into the authentication flow. And the first step here is going to be a Lambda we call the define authentication challenge. And this is just kind of a gauge. It kind of tells us where in the flow are they so far and helps us to determine where to send them next for the Lambdas. So the first step that we're going to send them to is the create auth challenge. We don't have a challenge for them. Let's go ahead and create one. In this case, we create a nonce, and we tell this back to Cognito, which stores it and sends it to the user. The user then receives this nonce and will reply together with the nonce and the signature that was on that email link. And these will get sent back to Cognito, where they're picked up by the verify auth challenge. Then this nonce and the signature, they're compared against private challenge parameters that are known by Cognito. If these are verified, if they check out, then we can be confident that this user is who they say they are. So if everything looks good, the define auth challenge will say, okay, great, we can send you on to token creation. So once again, we want to perhaps add a few user attributes in here so we can call our pre-token generation. But in this case, we want that more limited scope. So we won't attach that legacy auth token to this, but we'll add a few other things that may be interesting to the user for the scope that we're looking for them to have. So this reduced scope ID token and refresh token get returned to the user. This is an AWS blog post that we found very helpful specifically for this password authentication. It was a base, it's what we built off of. So I'll leave this up for a few seconds for you all to take a scan of it. All right, we'll move on. So what have we found from our implementation to Cognito? Well, one thing that we have found is zero downtime. For millions of users, we have found that the move from legacy auth to Cognito was virtually seamless. In many cases, they're able to use the same username, the same password. They didn't even know there was a change. And then from a back-end perspective, from a technology perspective, not all of our APIs needed to be ready and up to date, ready to adopt Cognito right away. We're able to use that legacy auth service still, the legacy auth token, to access these APIs in this kind of middle ground period. We went from having 3 different auth services we were trying to balance, 3 different tokens, all these different things going on at once, and we were able to bring it down to a single token. We were able to bring it down to a single authentication service. We're less attractive to threat actors. We've gone from 96 million password stuffing attempts on a given day down to about 1,000. Threat actors are not as interested when it's difficult to do what they're trying to do. So very good results there. We found that we moved from a 10-second onboarding from a user receiving a link and getting into taking a survey down to 2 seconds. We no longer have this middleman of, oh, I need to put in my username, I need to put in my password before you can even take an action. We're down to 2 seconds on that. And lastly, we saw a decrease in revenue loss due to fraudulent cash-out events. So what are some best practices? What are some do's and don'ts that we learned along the way? First, we found use SRP auth flow whenever possible. This prevents the password from actually passing over the wire across the internet and adds just that extra layer of security that we're always looking for. Make as many attributes read-only as possible. The reason for this is a user, when they're given their access token, when they're given their ID token, they actually will have the ability to modify according to the configuration that you've set up for the client, for the app client that they used to log in. So if there are attributes that are not set to read only, the user could modify these attributes. So as many of those that we do not want them to be able to modify, we want to keep them read only as possible. Use immutable attributes. So in your existing user systems, we want to take the Cognito user sub and add it into an association with that user in our existing systems. And likewise, we can take the ID in existing systems for that user and add it as an attribute in Cognito. This makes association between what existed before and with Cognito much cleaner and makes searching up the user across the platforms very simple. We want to use the pre-auth trigger to validate parameters, even along the different lambdas along the way. This helps to ensure that they are on the correct step that we actually expect them to be at a given time. And lastly, a good do, protect against password stuffing. So even if you do not necessarily use advanced security, although Dinata, we found it helped a lot, it may not fit your use case. So we would still encourage use CloudWatch, use CloudTrail, use something to notify and react to events that are anomalies in this sphere. Some don'ts. Do not use SRP during migration. We don't have the password. So if you don't have the password, it's going to create some friction for the user in the migration process. Do not trust the email if it's unverified. Pretty straightforward. We want the user to be actually associated and have access to their email before we start trusting it. Again, do not trust client validation attributes implicitly. So every step of the way, we want to make sure that we are checking, is everything lining up with what we expect? Do not forget to check the user not found flag. So if you find out that the user's not there, that's good. If you go to check user attributes, but the user's not there, you may fail them because, well, they're not lining up. But actually, the user wasn't there in the first place. So let's make sure we check that. And do not use case-sensitive pools. This helps to avoid conflicts in user creation. Some limitations we found as we implemented. There are 2 MFA options that are built in. There's software and there's SMS. Email is not a default available option for MFA. Custom takeover notifications. Sometimes you, as a user, find it helpful to know whether a login attempt was valid, was truly your own attempt, through certain attributes. So, for example, the IP, maybe the location, the device name. These things are not available when you're using custom notifications for takeover events. Something to keep in mind. You have to configure the messaging configuration even if you decide to use your own custom sending. So Cognito has a field to configure how messaging will go out. This needs to be configured even if you choose to use your own custom branding. And in a similar vein, the require MFA risk response will block attempts if there's no MFA set up for that user. So, as a result, if they don't have something set up, they will receive a block notification. If a block template is not there, then they won't be notified. So we need to ensure that when we are setting up the notifications, that we are including a block template, especially if we're using require MFA in any of these cases. This is a case study for more information on how Dinata implemented Cognito for our security features and the results that we found with it. And at this point, I'm going to turn it back over to Mahmoud.
Thanks, Caleb. And thanks, Alistair, for sharing these insights with us. It's really impressive to see the amount of customizations and combined flows that can happen, all of this while reducing password stuffing from tens of millions to 1,000 per day. Congratulations, this is really impressive results. So now in the remaining few minutes, I would like to talk about the other pillar that I mentioned. So detection is one thing, and putting controls in WAF and Cognito advanced security features. Protection is one thing. The other pillar is detection, being able to know what is happening in your identity layer and quickly analyze this data and where to look. This is where we spend the next few minutes. So as I mentioned, we took a layered security approach. We have different security controls at different stages, and all of these stages are emitting data at near real time in different sources. So you'll see all of the actions, API calls to Cognito are logged in CloudTrail. You'll see aggregate metrics in CloudWatch. You'll see utilization data in Service Quota, and so on. So where to look and what do you need to keep in mind? Of course, this is a deep topic on its own, so just a disclaimer, I can say that much in just the remaining few minutes. So I would like to share with you 3 things to take out of this session. The first thing is monitoring your traffic and baselining this traffic. Traffic information is available under usage category of CloudWatch. So you will see utilization of every API category in Cognito among several others. And you can do call counting and you can figure out more information about this traffic from Service Quota. You can call count and put these in dashboard, and this will show you the baseline of traffic. A better source to look at is Service Quota. It has the same information but with an additional important data point, which is what is the headroom you have before you start hitting certain quota. In this screenshot, for example, this is for user creation category, which are the APIs for user registration. And this shows at peak, I was hitting about 86% of my quota. And this is dangerous because now I don't have enough headroom. If this is a consistent traffic pattern or something that I expect, then I should definitely increase the rate limits for this API. If it is something anomalous, then I need my on-call engineers to jump into this and see exactly what's going on and identify the source of this traffic spike. From Service Quota, you can also create alarms at different thresholds. So you can create an alarm if you exceed 50% and above. And it is always recommended to create multiple alarms. So you create alarm at 50%, 70%, and 90% with different escalation levels to make sure that you have a soft heads up if you hit 50%, but then you have more escalations if you hit higher than that. This allows you to have a baseline of your traffic patterns and understand more about that and quickly identify any change in these traffic patterns, at least in the most critical APIs like user creation and user authentication. These are the most common and likely are on the critical path of access to your application. However, this data is available for all API categories as well. You can use it for that purpose, but at least user authentication and user creation are a must-have. The second data point I would like you to keep an eye on is the aggregate risk metrics that come from Cognito to CloudWatch. As I mentioned, Cognito does compromised credentials detection and calculates risk for every event. Where this aggregate data goes, it goes to CloudWatch. For example, you can put this data in one widget and have it in your dashboard. In this particular widget, I have, in this point in time, I had about 808 successful sign-ins. 81 of them had a risk, and this risk was compromised credentials. I didn't have account takeover, but all of this information will again help you build a baseline of what level of risk you see in your application or your environment. And you will always have a risk percentage of events will be risky. Many of the customers I work with tolerate about 3 to 5% of requests to have a risk. But if you suddenly see that this goes to 20%, 25% or so, this is an indication of an ongoing threat or attack, and you need to take action with that. You can create alarms on different of these risks from this little bell next to each metric. And this brings us to the next point, which is, well, I now know that there is an attack going on. How do I analyze this data and where to look to find these threat actors and identify these patterns? One of the easiest paths to do this is to have CloudTrail logs streamed to CloudWatch, and then you can use CloudWatch Insights to analyze and query this data. And you can configure this easily from CloudTrail to stream logs to CloudWatch log group. If you do this, you can run queries using CloudWatch Insights. This is a very simple query that is just finding correlation between sources and API calls and the count of by which these sources are calling these APIs. So this just a generic query that shows you this IP address is calling initiate auth or user authentication at this certain rate. You can run more advanced queries or like tailor the queries to your security requirements. So this is another example that's finding all sources that are getting not authorized exception and the count by which these sources are getting this error. So if you see something like the first 2 IP addresses, which each one is getting thousands of not authorized exceptions, if you don't recognize this IP address, it's not your back end or something that you know, then this is definitely a bad actor you need to take and block on WAF. This is more information about how to stream logs to from CloudTrail to CloudWatch and some example queries as well. You can take it and go from there. Another pro tip that I would like to share with you is, like, if you are not very familiar with CloudTrail event structure or how to build these queries, CloudWatch Insights has a query generator. You can just write in natural language what you are trying to do, and it's going to generate a starting query for you. It's usually very accurate and very good starting point. Running this query gives me the results I'm expecting here. So you can start with this, and you can use it to create these queries for analyzing user data. Of course, there are more ways to do that. You can stream these logs to another SIEM system that you might be using and use advanced queries elsewhere, but this is an easy way to get started with analyzing this data. So where to go from here? I would like to leave you with few action items you can take home and add it to your next sprint or something. To stay ahead of these threat actors, first, if you are using Cognito in production or not, activate firewalls on it. So you have seen the configurations that Alistair talked about. You have seen some of the configurations that is in the blog post I shared earlier. But this is a very important thing to have on your user pools. Cognito is a publicly available service. This means your application integrates with it through public endpoints available on the internet. So you want to protect these the same way you protect your APIs and your websites. Make sure you prepare dashboards, and as I mentioned, have these metrics in your dashboard and continuously monitor them and have alarms. Make sure that you have an escalation path for these alarms when they trip to your on-call engineers. Activate and evaluate advanced security features. Start with audit mode only, so you understand the baseline of your traffic and what kind of risks you are getting and what would be the impact of using enforced mode on your end users. And work your way out from there by soft enforcement, just allowing and having optional MFA. And then when you see the security posture is improving and more users adopting MFA, you can move to more of hard enforcement with requiring MFA or blocking. Still, implementing simple things like CAPTCHA on your public endpoints is helpful. It's not bulletproof, but it helps. It helps protecting from these naive attacks or things like this or bot attacks. Still, implementing CAPTCHA is helpful. So consider doing this. And then a general recommendation for any security team is to run penetration testing and examine your incident response runbook at least once a year. Like, it's better if you do this quarterly, but this will allow you to stay ahead of threats and being ready when you detect any threat pattern to start acting immediately. This is the end of my presentation. We have few other talks to you available in the conference to have some hands-on experience with Cognito through workshops and builder sessions. Some of these have already passed yesterday and this morning, but some of them are still coming. So happy learning. I hope you enjoy the rest of your day and the rest of the conference. Thanks again for joining us. Thank you.